Hey there, physics students. So we've just learned about significant figures, and we've learned how to round our answers to the correct number of significant figures after we do a calculation. And today I have a lab activity that's going to give us an opportunity to practice using our significant figures and rounding things correctly after we do a calculation. What we're going to do is that we have some plastic blocks. There's several different kinds. There's these clear ones, some of them are black, some of them are gray, some of them are white. You're going to take any one of these blocks, it doesn't matter which one, and what we're going to do is we are going to calculate its volume, and then there's a chart on your lab handout that tells you its density, and using that volume and that density we're going to calculate the block's mass. Okay? Then what you'll do is you'll put your block on a scale and see if you were correct. And you should be able to get the correct mass on your scale to the same number of significant figures as you calculated. Okay, so we're still working on being able to attend to precision in measurements. So let's go ahead and let's get started. Okay, if you look at your lab handout, it might be on paper, it might be a digital copy. On the front page, there are some questions for you to answer about your ruler down towards the bottom of the front page. You should get a ruler. I have here a meter stick. Get a meter stick, or you can get a regular ruler. For this, it won't matter. Keep in mind when you're using them, mostly they have an imperial side as well as a metric side. And which side are we going to be using? We're going to use the metric side. Don't use the inches, use the centimeters. Okay? And mine has centimeters on both this side and this side, so I can choose either side to use. Now I have my plastic block, and we are going to measure its length, width, and height. And if you look on the back of your lab handout, there's a place to record those. So I'm going to start measuring here. Okay, the block that I've chosen is this clear plastic block, and we're going to measure its length, width, and height, and I'm going to record them on this lab handout that I have here. So I've angled the camera so you can see, hopefully, pretty well. And what I'm going to do is I'm going to line up the block with the end of the ruler, line it up really nice here. Okay, and then we're going to read how far does this block go. It looks like it goes very, very close to 8 centimeters. Let's measure in centimeters. Okay, so it's at 8, but it's a little bit more than 8, it looks like. If I put my eye right over it here and I look, it looks like just a little bit more than 8, but it looks like it's not quite 8.1. So it's a little bit more than 8.0, but a little bit less than 8.1. So I'm going to estimate it's right in between those and say it's 8.05. That's my length. And we should be able to get 2 digits after the decimal point on our ruler here that we're using. So I'm going to say that the length of this is 8.05 centimeters. And it'll be important to include our unit there, centimeters, so we know what we measured in. Okay, let's measure the width. Line that up really nice, and I'm going to put my eye right over it. Looks like it's a little bit more than 3, a little bit more than 3.0, but it doesn't look like it quite reaches 3.1. So again, I'm going to say 3.05 because it looks like it's between 3.0 and 3.1. So I'm going to put 3.05 centimeters. And then let's measure the height. We'll line this up really nicely. I'll go ahead and put my eye right over it. Okay, this one looks closer to 2.4. Okay, you can see here's 2, here's 3, this slightly longer line here is 2.5, and when I'm really close to it, it looks like it comes to this line right here, which would be 2.4. and it looks like maybe a little bit less than 2.4, but more than 2.3. So more than 2.3, less than 2.4, I'm going to say 2.35. 2.35 centimeters. So now we have measured the length, the width, and the height of our block. Now we'll go and do some calculations. Okay, so now having measured the length, width, and height of my plastic block, I can now calculate its volume. So remember from geometry class, the volume of some kind of rectangular prism is the length times the width times the height. So I've taken 8.05 centimeters times 3.05 centimeters times 2.35 centimeters, and I get 57.69835. And the unit there would be centimeters times centimeters times centimeters would be cubic centimeters. So now, here's the thing, I have to round that number. That's a lot of digits in that number. And each one of my measurements had 3 significant digits. I had 8.05, which is 3 significant digits, 3.05, which is 3 significant digits, and 2.35, which is 3 significant digits. Remember, when we multiply, we have to round to the least number of significant digits. They all had 3. So I'm going to round to 3 significant digits. So I'm going to round this to 57.7. That 6 right there is the 3rd significant digit. And because the next digit's a 9, it'll go up to a 7. So 57.7 cubic centimeters. Okay, now I am going to look in this chart here that is on my lab handout, and I had a clear plastic block, and according to the chart, the density of that clear plastic block is 1.25 grams per cubic centimeter. Now what I'm going to do is I'm going to use the volume I just calculated and this density to find the mass of the block. Density is the mass divided by the volume. So if we rearrange that a little bit, the mass is the density times the volume. So I'm going to take the density in the chart and multiply by the volume I just calculated. So I'm going to do 1.25 times 57.7. Okay. And I get 72.125. Now, my volume, 57.7, had 3 significant figures. My density, 1.25, had 3 significant figures. So my answer should have 3 significant figures. So 72.125 has more than 3 significant figures. So we need to round this off to 72.1. So I am predicting that the mass of my block is 72.1 grams. Now we're going to go put it on a scale and see if we were right. Alright, here's the scale, here's our plastic block. Let's put this on here and see if we get what we expect. Is it 72.1, 72.0? Pretty darn close, right? 72.1, that's exactly what we predicted. So pretty neat there. Alright, if you didn't get the correct mass for your block, then try again. Try measuring a little bit more carefully, and then you should get it to come out pretty well. If you did get it to come out and you got time left in class, then go ahead and do another block. It doesn't take all that long to calculate the volume and to calculate the mass. So do another block if you get the time. So hopefully that helps us to be able to attend to precision in measurements. Till next time, take it easy.